Got it. Okay, so learning a language, I think it's best to do it and learn it a little bit. So I have put together like a small workshop. I am also a beginner in Rust, so it'll be helpful if we can, it's more of a knowledge share style of learning. And I'll first, the structure is that first, maybe I'll give a small introduction on how to get started with Rust. And then we will look at how a normal Rust code is structured. And then we will do a small exercise in the end. So like maybe say 15 minutes for the exercise and 5-10 minutes for the rest of the stuff. I wouldn't say it's long. And it's a beginner level, the basic stuff to get us up and running. And I wouldn't be discussing much about the language construct itself, like they are similar, like, you know, for loop, while loop, all those things. I'm just gonna skip because it's common between the languages. But more, I'll be focusing on the project structure and writing tests, so that, and then we can, once we have a little bit of understanding, then we can decide on what are the advanced topics to discuss. Does that make sense?
I'd love that. Thanks, really.
Okay. So I have put together a markdown. It's a short one, just to give a brief intro on Rust. So Rust is mainly a systems programming language, and it's designed for safety, speed, and concurrency. So there is interesting usage of Rust in WebAssembly as well. But yeah, mainly it's used in systems programming, but it's a generic purpose language. Like you can use it for almost anything, I believe. And then the main thing about Rust is that it is a lot of compile time features, which helps us avoid common bugs, especially when doing systems programming with the likes of C or C++ and things like that. There are random bugs like with memory and stuff, which Rust helps us avoid. It's built into the language to avoid those bugs. That makes it a bit interesting. Sorry. Oh, this echo.
Yeah, I just unmuted.
Okay. Shin joined it from a laptop, so there's an echo. Sorry. Anyway, where to find help? So the Rust is pretty well documented. It's very easy to go to the Rust website and get started. And I love, as Asim, I think you had mentioned before, right? Like that you love the documentation on Rust.
Yeah, absolutely. The Rust documentation is one of the best. I've never seen any language having such awesome documentation.
Yeah, so it is like anything under Rust, you can just go to the website and it is there. You don't have to buy a course or something. You can learn it from the book or using examples. There's like, it's really good. It's excellent. And that is one of the reasons I think it's popular, because if things are easy, people tend to use it more. And yeah, so this is their website. Just show. So yeah, you can read a book, do the Rust links course. This is really good actually. And you can also check out Rust by example. There's a load of cookbook, everything is there. So it's very well documented, and you know, as a playground as well. So yeah, it's a pretty good documentation. I just wanted to highlight that because it's really good. And to install Rust itself, it is as simple as doing a curl command. For Linux and Mac at least. For Windows, I think there is a setup or something. You can download and install that, and it's available to work. But mainly this is I personally like with Node we have NVM, and with Rust we have Rust up. It's really handy to install and uninstall runtime like languages like that. So you can run this command, you have Rust. And you have more options here, like for Windows or other OSs, you have the options here. And basic code for Rust look like this. It is so simple. It's if you have done C or something like that, it'll look very familiar. It's just a main, and then you can do whatever you want inside the main. And main is like the entry point into Rust. And
is it like, sorry, Sachin.
Yeah,
So
no,
is
go
it-
ahead, interrupt me anytime.
Sure, that. Is it like the function in Rust is like a first class object? So you don't need to create a class to
No.
create the function. Good
Yeah,
stuff.
So you just fn main, and you have the function main there.
Oh, interesting. Like
That's it.
Python, isn't it? Good stuff.
Yeah, kind of like that. So, and this is the entry point.
All right.
So the file will be with .rs.
Yes, extension.
Yeah, thanks.
And then compiling and running it also is as simple as, you just, don't need this part. I was cleaning up the previous binary. So there is your main.rs, and then you just go rust c main.rs. So if you have used Java, it's like Java C, and then it'll generate for Java, it generates the bytecode, and Rust generates the executable file, and then you can just execute it /main, and then you run the program, and that is it. So this is like the very basic basic how-to on running Rust. So this is more than enough to get started. But as the project grows, it's obvious that this won't be very good. Like for example, if you want to use a library and things like that, you'll have to tell the compiler to link the library in, and it just gets out of hand after some time. So for very small projects, this might be acceptable. But for large scale projects or even a medium scale projects, it might be, hey, Ash. Yeah. So for large scale projects or medium scale projects, this might not be the ideal. But to try things out, I feel this is handy, just to randomly experiment on stuff. This is pretty handy. Just using the like learning something about Rust or doing something like that. It's kind of handy. And for scalability, we have Cargo. So Cargo is Rust's own build system and package manager. So it is like if you have used Node or something like that, we have npm as the package manager. So it is kind of like that. It has a similar workflow as well. It has a manifest and things like that. So Cargo makes lives a lot easy with when living with Rust, and it handles things like building, downloading the dependency, and a whole plethora of stuff. Cargo handles, makes our lives easier. And so even creating a new project, Cargo makes it easy. It has templates. So if you do Cargo new hello Rust, so if you run this command, you'll literally be creating a new crate called hello Rust. So you're creating a package called hello Rust, and you can see it here. I'll talk a little bit more about binary and other library packages later, but by default, Cargo new hello Rust creates a binary package. And then if you look at the tree of the directory, you will have the cargo.toml, and you have your source folder and your main.rs located inside the source folder. And cargo.toml is the manifest. So, I'll go here, but yeah, anyway, cargo.toml is the manifest, and your RS is the source code. And if you just do cargo run, it will compile, so it will build and it will run the executable. The executable is by default generated into a new directory called target, and target will have hello Rust. And
Question. Is the cargo similar to Maven then?
yeah, kind of like Maven in Java.
Okay.
Yeah, it's a package manager. Maven is yeah, you can call it Maven or Gradle, something like that. Yes.
Oh, okay.
And by default, when you do cargo build or cargo run, it creates a debug binary. So it is unoptimized. It is better for debugging. It's more for the developer to debug. And hence it generates it by default into the debug directory under target. But if you use the flag -- release, then it will optimize the binary. It'll run. It has a couple of optimizations. I'm not very well versed in model optimizations. It does, but it's I believe it is a production ready binary that will be built into target/release folder. Yeah, we can try this out later. I'll just run these commands and show it towards the end of it. And then with cargo comes the concepts. With cargo and Rust comes the concepts of packets and crates, packages and crates. So a crate is a binary or a library. So you can have two types of packages per se. It's either a binary application, which is just an executable that you can just run it like this, or a library. Library will have usable functions, and you need a binary in the front to execute it. So by default, when you do cargo new package name, it does the binary package. And the crate root is a source file the Rust compiler starts from and makes up the root module of a crate. So here main.rs is the crate root, for example, and then whatever is, so it's like if you have done a little bit of C, like it just starts from this place and then it links various stuff to it, and then finally you get the binary blob which you can run. And crate usually groups related functionality together in a scope. So usually we say a random number generator, something like that. Sorry. We group those functionality into crate. And package is one or more crates. So you can have multiple crates inside a package. So it's next level of abstraction. Package can have one or more crates, and the package will contain a cargo.toml. So as you can see, you have this is a package. That's a cargo.toml file that describe how to build those crates. Cargo.toml is the manifest file. We'll look through the contents of it briefly, but it is mainly the manifest file. Yeah, if you have used npm, npm, something like that, it's for me it's kind of very similar to package.json. Or yeah, in the build or Gradle file or something similar. And okay, and there are some conventions in Rust world, and one of them is that when cargo creates a package, it'll have a source/main.rs. This is the crate root for a binary crate, and it assumes the name of the crate is same name as the package. If the package contains source/lib.rs, it assumes the package contains a library crate with same as a package. This is similar to this. And a package can contain both as well. It can contain a main.rs and a lib.rs. And this is usually the preferred way of writing small code. Like you will have a main.rs and a lib.rs. So it has a library and a binary. Library will have your functionality, and the binary will be a front end for it to execute stuff. A package can have multiple binary crates by placing the files in the bin directory. So this is at first this is a bit confusing. Like you cannot just add stuff directly into source directory. If you want additional binary files, you need to create a bin folder and put it inside the bin folder. Those are just conventions. And you can build or compile the binary file separately with cargo later. And so this is in general, this is how Rust lang is organized. The Rust package is organized, and package is like the exportable module there. And now coming to the next part, testing. So there is like a documentation test, unit test, and there's like a variety of tests. But I think for beginning, like for starting, like we have two main categories of tests, like let's say unit and integration tests. Unit tests are usually put in the module called test. So say this is your lib.rs source. So if this is your source / lib.rs and it has a function called adder. So this is the visibility. You can have, by default, everything is private. You can add a public so that you can export a function like this. And this is a normal structure of a function here. So it just takes in 2 integers and outputs another integer. And this is the return value. You don't have to specify return in Rust. So if you write an expression there, it is assumed that that's how the function returns a value. And for now, I'm gonna ignore this. Like we will discuss about this later. This is like an annotation, for example. This is like if you have used Java or something like that, you'd be familiar with @test. So think of this like that. And then this is just an enabler. Like it enables this module to use whatever is defined outside. So I just say use superstar. So superstar is everything outside. And this just enables to use whatever is defined here inside the scope. And this is very helpful. This is a very helpful line, especially for testing. And this is just a normal test. So you can, and when you do cargo test, it will run this test. You don't have to do anything fancy. If you have, so small tests, like if you have written Python, you would write some small unit test at the bottom of the page, of the file. So this, you could think of this like that. And for integration test itself, they are usually put into a tests folder. Make sure there is an S in the end, else cargo won't detect it. So there's S in the end. So besides source, you can have a test file at the project root, and when you run cargo test, it will run the test. It will run the integration test as well. The only thing you have to note here is that cargo might try and run tests in parallel. So don't have self-contained tests. Don't have tests that rely upon other tests. That is something I've observed here and there. Like some folks write tests in sequential order. I'm not a fan of that. And it's with cargo, I think they kind of say don't do that. And yeah, so tests should be independent is something I believe. And this is something I like because of that as well. So this is a simple test. So you just say, for example, if it is this, you will just be saying, like say this module is named, this crate is named adder, or summation or something. So you just be using summation adder and then assert equals, and that's it. And you run cargo test and your tests are run. Basically, that is it about Rust as for starters. And I'm proposing a simple exercise where we create a calculator. Like you can download, install Rust, and then we can take 15 minutes now to do this exercise. Like it will just create a simple calculator. Like it can take the program will take in 2 ints and 2 ints operator. When general operator. I don't know why is it showing that. Oh yeah, oh star. What's the result? Okay, so I'm proposing a small exercise like this. We will, so if you haven't downloaded Rust already, we will take 15 minutes time check, maybe 15 to half an hour a time check. And then we will download the Rust. Maybe you can try this cargo. You'll run cargo new project, and then I'll show basic structure, and then we can create this package, and then we can learn from each other. We can share the solutions on what they have done, and have a small discussion about this and wind up. I'm proposing, and I'll show a simple version of it. I just created it like what 5-10 minutes ago. This is okay. Oh, sorry, I have the this is the basic directory structure. You have the cargo.toml, you have the source, target, and test. And in the source, you'll have like say main.rs. And so in the main.rs, you're just reading in to operators and then an operand, sorry, an operator. And then in your, so this is how you normally read something from the line. I have put it as help you. I'll share it in the group. It's nothing fancy. You're just using standard IO, and then you are reading a line and then parsing and unwrapping it into a integer variable, and then performing the operation itself. And you have the test here as well. Yeah, go ahead.
Yeah, there's two questions. Sorry. The simple one is, you said the cargo will create the target directory and then they'll put the binary there. And do
Yeah.
we have to create the target further, or it's just they would do that for us?
Everything is done by cargo. So I'll show it to you. For example, I'm saying cargo new, let's say narrate test.
Test me.
Yes.
Sorry.
This package is intended for Tom. And then if you go to
Sorry, I'm but like, what if you remove the further first, and would they create the target as well, or it'll just throw an error?
It'll create the target. No, it'll create the target again. So now if you look at it now, there's nothing here. See, there's just a source.main.rs and a cargo.toml. There's nothing else here. Now if I do cargo run, it'll generate whatever is there. See, now it created a target directory.
Interesting.
You can see there is a target directory now. It was created. And then if you do cargo, oh yeah, I actually did cargo run. It will even execute the binary. This is the binary.
So whatever you write something in the main dot or s, then it creates the package from there, is it? Or
yes, so that will be like the root, and then you build from that root.
Yeah, it's completely different from how Python works, you know.
Yeah, that's stuff. And then another
that's one important. Also, I would like to add one interesting stuff with Rust. The if else and the loop is a bit different from other programming language. So in programming language theory, there is a concept called statement and expression. So in Rust, these if else statement and while loop are expression. That means they return the value. But if you consider programming language like C or C++, they are pure statements. So that's another interesting stuff in Rust. So when you write code, just remove that semicolon and you don't need to write explicitly any return statement, and that particular block will return that value. So it's more like Lisp. If anyone has ever tried Lisp, it's like Lisp. But yeah, so that's one interesting difference between other programming language and Rust.
Yeah, that's kind of my question as well. Like I'm kind of not fully get it. So you don't do return, and you said they will catch what you are meant to
Yeah,
throw.
what's your last statement? So for
The
example,
last statement. All right.
yeah, so for example, if you have a if else block, either the control will either fall into if block or else part, right? So whatever be the last statement of if block or else block, that is going to be the return statement. So that's called the expression. Expression always return things, but statement doesn't. So these control flows in Rust are kind of expressions, but that is not the case in other programming languages like Java or maybe even C, C++. They're pure statement. You have to write explicitly return.
Yeah,
it's more of a very old way. I mean, Lisp is quite old programming language. Just adapt that approach of expression, you know.
So thanks guys.
Yeah. But yeah, like in the beginning, it's just easier to learn it, like just another language, like, you know, just create some stuff. And then once you get into the step, once you start the step one, then it's easier to build on it. It's easier to understand as you go along. And if you just, like, personally for me at least, if you just try and understand the deepest level of stuff in the first iteration of learning, then it might be a bit mind-boggling and putting off on learning. But it's a beautiful language. Like it is actually a really nice and cool language. Yeah, it has its good quirks. Like for this example, okay, time left is 9:32. Anyway, we can take a time check. Just this is just me showing how the variable declaration works. This is like a loop, so you just loop through it. This is a while loop, and this is like the Rust version of, say, switch case. And yeah, all of this is in their website, but I think it'll be beneficial for us to just create this this application now, and then you know, just share the code between ourselves.